All right, let's go over, this is Unit 5, Graphing Log Functions DBA. Just want to give a project intro, just so that you can see exactly how to relate exponential functions and log functions. I think exponential functions will help us. So just as an intro here, let's think about y equals 2 to the x. So hopefully we find this to be pretty straightforward. I'm just going to choose a bunch of values near 0 to plug into x, and let's see what happens with the y value. So if I plug 0 in for x, 2 to the 0 power is 1. So 2 to the 0 power, that's the same thing as 1. We can plug in the calculator to verify that. If I plug 1 in, 2 to the first power is 2. If I plug 2 in, 2 to the second power is 4. And then 2 to the third power is 8. Okay. 2 to the fourth power is 16. I'm just plugging enough values just to kind of give a general feel for the path of the graph. Now, -1, let's see what happens with -1. 2 to the -1, okay. If you plug in the calculator, that's the same thing as 1 over 2. Basically, that negative exponent is going to take this base and flip it to the denominator. So 2 to the first power in the denominator is same thing as 1/2. And then 2 to the -2 is same thing as 1 over 2 squared, which is 1/4. So let's plot these points. I want to show you what that looks like. So 0, 1, 1, 2, 2, 4, 3, 8, 4, 16. Okay, so 4, 16 is off my graph here, so but we can kind of imagine that the graph is rising at a very steep rate. Okay, -1 gives us 1/2, really close to the x-axis, and -2 gives me 1/4, even closer to the x-axis. So that's actually going to tell us where that horizontal asymptote is. So I want to kind of show you what this graph looks like here. So there's my exponential function. This is my y is equal to 2 to the x power. Okay. Now the reason I'm showing you this is because this exponential function is going to be related to the log function that you're going to be graphing. So exponential functions and log functions are inverses of each other. I say log, but it's just short for logarithmic function. So for instance, the first one you're having to graph is this y is equal to log base 2 of x. It's related very much to this y equals 2 to the x. The only difference is that all your x and y values are going to be swapped. So I'm going to carry down these values that we found. So 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, -1, 1/2, -2, 1/4. And now we're just going to take these values and we're just going to flip them. All right, so instead of 0, 1, my log base 2 function must have an order pair of 1, 0. Because these are inverses of each other, meaning that if they're true inverses, they're always going to have flip-flop versions of their order pairs. So I'm just going to copy these numbers over, but I'm just going to switch the order of these order pairs. So 1, 0, 2, 1, 4, 2, 8, 3, 16, 4, 1/2, -1, and 1/4, -2. So I'm going to take these order pairs, and I'm going to put it on this graph to kind of show what the log function looks like, and also to show that there's something unique and special about the way that a log and exponential function, inverse functions, are going to look next to each other. So I'm going to plot these order pairs here for the log function. 1, 0. For log function, log base 2, I have 2, 1. 4, 2. 8, 3. 16/4. That's a little bit off my graph, but I can do these last ones, right? 1/2 -1, and then 1/4 -2, really close to the y-axis now. So this is what log functions will look like. It's going to kind of hug the y-axis here, it gets closer to it, but then it's going to rise, but at a very slow rate. So what we're looking at here is the y is equal to log base 2 of x. Oops. Log base 2 of x. So a true function and its inverse will always look like they're folded over the line, this diagonal line y equals x. So I can draw this diagonal line, and you can kind of visualize, right? If you were to fold this graph over this dotted line that I created, we can kind of visualize how these two will kind of overlap each other. Okay. So not only are the order pairs flip-flopped between a function and its inverse, their domain and range will also be flip-flopped. So if you think about the domain and range for y equals 2 to the x, this graph here extends all the way from left to the right. I know it looks like it's going straight up, but it's actually moving to the right. A little slower, but it's rising faster than it's moving to the right. So it's actually going to extend all the way left, all the way to the right. So we say domain is all real numbers, -infinity to +infinity. Now the range is the lowest to highest y value. We see that for this 2 to the x, the range is lowest y value is 0, right? It's never going to touch that x-axis, but it's going to rise to infinity. So we say 0 to infinity. Okay. Now let's consider the domain and range for log base 2 of x. So domain, we see that there is an obvious stopping point, right? The domain is from 0 to infinity, right? The furthest left it goes is not going to get past this vertical asymptote, this y-axis. So we say domain is from 0 to infinity. And then the range, we see the y values will extend from -infinity, right? This goes all the way down to -infinity, and all the way up to +infinity. This arrow will continue going up. So the range is all real numbers. Now, we know that their order pairs are flip-flopped between exponential function and log function. And we can also see that their domain and range is also flip-flopped, right? You see that the range for one is the domain of the other, and the domain of one is the range of the other. Okay, so hopefully this will kind of help you get started with your project. You're also having to find order pairs for log base 3 of x and log base 4 of x. So my suggestion is think about y equals 3 to the x, create your order pairs for 3 to the x, and then you can use that to flip-flop to the true order pair for log base 3 of x. And same thing with log base 4 of x. Create order pairs for 4 to the x, and then, which is more straightforward, and then once you get that figured out, then you can go about flipping all those numbers to get the your log function. All right, so hopefully that helps out. So good luck with the project, and I'm sure I'll help you if you're stuck or if you need any more support.